Okay, now we will start solving this problem. We have already seen how to formulate the linear programming problem, and we have already obtained the objective function as max p is equals to 20x plus 30y, subject to the three restrictions, three constraints, that is 60x plus 80y is less than or equals to 48,000, 40x plus 40y equals to 28,000, and 1.5x plus 3y is less than or equals to 1500, and xy is greater than or equals to 0. Now we will see how we can solve this problem using a linear programming problem. In fact, we will use a special kind of method to solve this, as this is a two variable problem. As you can see, there are two unknowns over here, x and y are the two decision variables. So we will be using graphical method of solving this problem. If it's not, nothing is specified, if there are only two variables, it is always easy to use graphical method to solve the linear programming problem. So let's start using graphical method. So to do that, we have to recapitulate a little bit of drawing a graph. I hope you remember how to draw a straight line, because those information is required to solve the using graphical method. Let's draw a graph first. So in a graph, as you know, we have the x-axis as x, o, x dashed, and y-axis as y, o, y dashed. So since we have the non-negativity restrictions, that is x and y are greater than or equals to 0, we will concentrate our discussion within the first quadrant. That means in the first quadrant, as you know, in the first quadrant, the value of x and y, both of them are positive. So we will just restrict our discussion in the first quadrant, and we will be using the method, the rules to draw the equation of straight lines. So first we will start with the constraints. So the first constraint was 60x plus 80y is less than or equal to 48,000. So that was the first constraint. Sorry, it's 80y. So 60x plus 80y is less than or equal to 48,000. So first thing we will do is try to draw the corresponding equivalent straight line for that. To draw that, we will use the intercept form. If you remember that the intercept form of drawing the straight line is x by a plus y by b equals to 1. That is the intercept form of drawing a straight line. If you can write the equation of straight line in this particular intercept form, then this straight line passes through the point A0 and 0B. So those two are the required points. If you can place the points on the graph A0 and 0B, then the straight line will pass through those 2 points. As we know that we require only 2 points to draw a straight line. So A0 and 0B are my required points. So we'll try to write the equation in that particular form. But before that, let's indicate on the x-axis and on the y-axis, let's indicate some scale. Let's indicate on x-axis and y-axis, let's define some scale. As you can see, if we transfer it, will be around about 100 and 2000. So let's say 100 and 200. So let's make this. So this is 200. We'll take this length as 200, then 400. I'm trying to use eye estimation over here, but for better kind of drawing, you can use the do not use eye estimator. Better to use the scale. So please use scale while drawing the graph. So 200, 400, 600, 800 and 1000. And in the y-axis also we'll put some scale. So say suppose this is 200, then 400, then 600, 800 and 1000. I hope this is sufficient. So in x-axis and y-axis we have put the scales, and as we have said, we will write the equation of straight line in the form of, so we will take the equality sign and instead of less than equal to sign, so we put it equals to and try to write it in the intercept form. So if you divide by 48,000, then the equation becomes x by 800 plus y by 600 equals to 1. So that means this straight line, for this straight line, the 2 points are 800, 0 and 0, 600. So through these 2 points we can draw the straight line. So this point is 800, 0. This is your particular point is 800, 0. That means the value in the x-axis is 800 and the value in the y-axis is 0. And in this case, this point is 0, 600. So this point is 0, 600. That is 0, 600. And we will draw the straight line using these 2 points. So please use scale while drawing this straight line. So I am trying to. So this is the straight line which is equivalent to 60x plus 80y equals to 48,000. Now what happens, this particular straight line divides the plane of the whiteboard into different halves. One is towards the right side of the line and one is towards the left of the line. And actually our equation was, we had inequation and the constant was 60x plus 80y is less than equals to 48,000. So these two halves are called hyperplanes because hyper means half plane. So this line divides the whole plane of the whiteboard into two hyperplanes, and one of the hyperplanes satisfy our condition. So one of the hyperplanes satisfy our condition. So to check that which hyperplane satisfy our condition, what we do, we choose, you can see there is a point 0, 0 is a very known point, and this known point 0, 0 can be put and check whether that known point satisfies our condition or not. So if we put the value of x as 0 and y as 0, so that left hand side becomes 0, so 0 is less than equals to 48,000, and we ask the question whether that statement is true or not. Yes, that statement is true. So 0 is less than, we will be putting the value of x as 0 and y as 0 to just check. So 0 is a point which belongs to this side, and if the condition is true for 0, 0, then that side which is having 0, 0 will be the side that satisfies our condition. Otherwise, the other side which does not satisfy, which does not satisfy the condition will be taken. So that means here if we put 0, 0, so 0 is less than 48,000. That statement is true. So that side which is containing 0, 0 satisfies our condition. So we will put an arrow like this. So this arrow indicates that our region of discussion is this side of the graph. So it's left to the line. Similarly, we will try to draw the two other equations that we have as our constant. That are second constant was 40x plus 40y was less than equals to 28,000. So if you ignore the inequality sign and take the equality sign, so to transform that to x by a plus y by b form, then it will become x by 700. So if you divide it by 28,000, so it will become x by 700 and plus y by 700 equals to 1. So in this case the 2 points are 700, 0 and 700, 0. So 700, 0 is somewhere in between 600 and 800. So this point is 700, 0. And similarly in y-axis, this is in between 600 and 800. So this will be this point is 0, 600. This point is 0, 700. So this will join these two points using a straight line. So like this, and similarly we'll check which side of the straight line satisfies our condition of less than equals to, and again we have this point 0, 0 in this side of the line, and so we'll put 0, 0 over there and check whether that satisfies or not. So 0, 0 means 0 less than equals to 28,000 is also true. So that means for this equation also, this side satisfies our condition. Okay, let's put a name to these two lines. So first line I have drawn. So this first line I am putting the name as A and B. This is the equation of the straight line. I am naming that as A and B. This line I am naming this as CD, and this intersection point, say I am naming that as M. I am naming that as M. So I have already drawn the two constraints. The third constant was 1.5x plus 3y is less than equals to 3000. So if we take sorry, not 3000, it was 1500. It was 1500. So similarly we can draw the line as x by 1000 and plus y by 500 equals to 1. So that means this is the point passes through 1000, 0 and 0, 500 is somewhere here. 500, 0. This point is 0, 500. This point is 0, 500, and this is this point is 1000, 0. So you need a scale, I think. Maybe you have made a mistake in drawing. Without a scale, it's very difficult to draw something like this. And if we put 0, 0, so 0, 0 side satisfies our equation. So for this third equation also, so this will be our direction that satisfies our condition, and we'll put the intersection. So I put the third equation, let me name this as E and F. So third equation we put the name as EF, and the intersection, say this, I'm naming this as N, and this is M, this point is M, N, this point is M, and say this point is L. Okay, so we have drawn all the three constraints, and all the three constraints as represented as straight line, although it may look like not like a straight line, but yes, while you draw, you use scale and pencil to draw in straight line. Draw a straight line. So please, so we have already drawn the three constraints as three straight lines. As we have said, this is a linear programming problem. So we are getting all the different straight lines. Now, next important thing is to find out the feasible region. Now, what is the feasible region? What is the definition of feasible region? Feasible region is that region which satisfies all the constraints as well as the non-negativity restrictions. So in this case, our non-negativity restriction is the first quadrant. So everything that is there in the first quadrant, as well as every part, as well as the part of that part of the graph which satisfies all the three constraints. So that is why I put this arrows downwards, because in this case we will find out that region which satisfies all the three constraints. Actually, if you look at carefully, this is the region, or you can say that region which is common to all the three constraints. The region that is common to all the three constraints is our feasible region. It's called feasible. So we name this feasible, F-E-A-S-I-B-L-E. And if you name, like we start from E, then M, M, so E, N, M, D, O, E. E, N, M, D, O, E is our feasible region. E, N, M, D, O, E is our feasible region. See, E, N, M, D, O, E. So as for this region, if the region starts with a letter and ends with the same letter, then that region is a closed region. It's a closed region because it is bounded by all the different straight lines. So this is one straight line, this is one straight line. In fact, 1, 2, 3, 4, 5 straight lines. So EN is a part, MM, then MD, DO and OE are the 5 different straight lines that is binding this region, and this is feasible region. And it is not necessarily always the region will be feasible region will be bounded, but in this case it is bounded. There is a boundary to it, and it is called feasible because it satisfies all the constraints as well as the non-negative restrictions. Now, why we have not chosen? So if I take a point over here in this region satisfies this straight line, this straight line. In fact, it satisfies CD and AB, but does not satisfy EF. So that's why this part will not be taken. And if you choose something here, any point here, this point satisfies EF and AB, but does not satisfy CD. So the common region under all the 3 straight lines is the feasible region, and this feasible region is, for this particular problem, is EN or the ENMDOE. This feasible region is ENMDOE. So we have already drawn the constraints and we have already drawn the feasible region. So we have used up the constraint as well as the non-negative restriction. So final thing that is needed to be done is to find out the objective. So what is the objective? So we have now we will do something with our objective function. The objective function was 20x plus 30y. So our profit is 20x plus 30y, and we have to find out that value of x and y which maximizes my profit. So now the feasible region means you take any point within this value, within this region, that is a solution. That is a solution means that value satisfies all the 3 constraints. So if you take any point inside the feasible region, that gives you a solution, a particular combination of A and B, the number of units of A and number of units of B that it may produce within that particular feasible region. But that particular combination does not necessarily give you the maximum profit. So our objective is to find out that particular solution, or maybe more than one solution, for which the profit that will be obtained will be maximum. So if you take any point in this region, all of them will give you a profit, but that does not necessarily be the maximum profit. So for maximum profit, we have to do something else. So for that, what we need to do is, now there is a theorem in linear programming problem, or the rule that we will be using to find out the optimum, in this case is maximum, is that in a feasible region, the maximum point or the optimum point occurs at the corners of the feasible region. the optimum point occurs at the corners of the feasible region. So corners means the end point, the edges. So like here, how many corners are there? E, N, M, D and O. So this is a closed region, this is a closed feasible region which is having corners E, N, M, D and O. So what we need to do? We need to find out all the points, all these points E, N, M, D and O, and we have to find out the corresponding profits. So I can write PE means profit at the point E, PD means profit at the point D, PN means profit at the point N, PM means profit at the point M, and PO means profit at the point O. So what we'll do, we'll find out the profits at the corners, different corners, and find out of them which one gives you the maximum value, and that will be our solution, So for that we have to find out. So we have to find out the points E, O, D, M and N. Now from the graph, it can easily be seen that this point E, the point E is nothing but 0, 500. Point O is 0, 0, and point D is 700, 0. But points M and N can be found out from the graph paper if the graph paper is used. Otherwise, we need to solve the equations to find those points. That means the point N is the intersection of the line EF and AB. You can see the point N is the intersection of the line EF and AB, and the point M is the intersection of the line AB and CD. Point M is the intersection of the line AB and CD. So solving AB and CD, you can find the value of M, and solving AB and EF, we can find the value of N. So solving AB and CD, we can find the value of. Now when you solve, you can see actually if you solve the equations AB and CD, ABCD, and to find M and N, AB and CD to find the value of M. So solving AB and CD, we find M, and solving AB and EF, we find N. And when you actually solve it, you find that both the values are same. Actually, the data that I have given in this case is M and N are coming at the same value, coming at to the same point. That is, I think it will become x equals to 400 and y equals to 300 in both the cases if you solve. So you check and you solve. But so that means our drawing is a little bit wrong, some shift, because as I have drawn it without scale, so it is happening because of that. So to make the graph correct, so what we can do is to change the data again a little bit. So we'll change the data a little bit again. So in this case, we will change the third equation, data of the third equation again a little bit. Instead of 1.5x plus 3y, we have taken 1500 previously. So now we'll just change a little bit, we'll make that 1560, so that this graph will become right. So in that case, the equation of straight line becomes x by 1040 plus y by 520 equals to 1. So instead of, the line changes, the line EF changes to 0, 520, and this point F becomes 1040, comma 0. So here the 2 points are 1040, comma 0. That is the point F, and the point E becomes 520. So I'm just changing a little bit, changing the data, more or less 1000 and 1040 is similar, near about. So I'm changing the data a little bit to make the graph work like this, so that M and N are the two separate points, and those, in that case, our solution, if you solve the equations, we will get, so solving AB and CD, we get the point M, solving AB and CD, we get the point M as 400, 300, and we get the point N as, and we get the point N as 320, 360. So the value of M, how do we get the value of M? M is the intersection of the point of the straight lines AB and CD. So solving AB and CD, we get the value of M. At the point M, the value of X equals to 400 and Y equals to 300. And solving the equations AB and EF, we get the point N, and in there X equals to 320 and Y equals to 360. So these are the two solutions of M and N, and then we will find out the value of P at those points. So P at the point E equals to, so we have got M equals to 400, 300, and N is 320, 360. So PE means value profit at the point E. So we put the value of X equals to 0, that is 20 into 0 plus 30 into 500, that gives 15,000 rupees. So profit is 15,000. Obviously for PO the value becomes 0 because both of the values are X and Y are 0. P and profit at the point D equals to D is X is 700. So that means 20 into 700 plus 30 into 0, because the value of Y is 0, that gives you 14,000 rupees. P profit at the point M equals to M is 400 and 300, so that is 20 into 400 plus 30 into 300 gives you 8,000 plus 9,000, that is 17,000, and value at the point N, profit at the point N is equals to, N is 320 and 360, so 20 into 320 plus 30 into 360 gives you 6400 plus 1080, sorry 10800. So 36 into 3 is 108, so 10800. So that means this gives 200, 8 plus 4 is 200. Sorry, this becomes 17,200, I think. 8 plus 4 is 2, yes. 16 plus 10, 6 plus 10 is 16, and 8 plus 17,200. So at the point N, the profit is 17,200. At the point M, the profit is 17,000. At the point D, the profit is 14,000. At the point E is what? Profit is 15,000. So maximum profit is at the point N. So the value of the maximum profit is 17,200, and for this the number of units of A that is produced is 320 units, and the number of units of B produced is 360 units. So finally we can write, so that means this point N gives you the optimum profit. This point N gives you the optimum, means in this case is maximum, that is the maximum value is 17,200. So finally we will write the answer as, hence the company will produce 320 units of A and 360 units of B, and those units will be sold in the market to obtain the maximum profit as rupees 17,200. So this gives you the maximum, this gives you the solution of the decision variables. So decision variables of A and B, the number of units of A and B were my decision variables, and also it gives you the value of the objective function as a maximum value of the objective function as 17,200. So that completes our discussion of linear programming problem and how we can formulate the linear programming problem and how we can draw a graph. And after we draw the graph, we find the feasible region, and after finding out the feasible region, we find out the corner points. After obtaining the corner points, we put the value of the corner points in the objective function to find out whether it is maximum or minimum. According to the problem, we find out what is maximum, whether it is maximum. If it maximum is asked, so find out the maximum, we'll take the maximum value. If the minimum is asked, we'll take the minimum value, and that will give you the corresponding values of x and y will give you the solution. That completes our discussion of LPP. Thank you.